There's another really good example of exponential growth that has happened recently.
GameStop?
We're talking share prices, are we?
Yep.
That is probably not quite exponential growth, but if you have a look at this kind of graph over here, right, this again tries to highlight the same kind of thing, right? We have a pattern here, we have a linear sort of expression where things are increasing by what, 3s or something, right? And then this is exponential. It's not base 2 this time, it's base 3, right? So you've got 3 to the power 1, you've got 3 squared, you've got 3 cubed. And it's just trying to highlight how quickly things can grow. Because by day 7, the linear pattern only has 18, but the exponential has 729. And again, in 2 weeks' time, right, you can see how big of a difference there is there. Where else have we seen exponential growth kind of pop up in our, yeah?
Like a virus spread?
Like how fire spreads, maybe like all the leaves.
Like a virus.
Oh, virus. Oh, right, a virus. A virus is a great example. In fact, the coronavirus, COVID-19, is one of the greatest examples we've looked at. Okay, so during the COVID-19 break, they were talking about this thing called a growth factor, right? And so basically, if this number is above 1, it means that it's not going to be very good. It means that it's going to be growing very quickly, right? But something that's below 1, it means that our cases are going to be stable. They're going to be dropping over time, right? But there's kind of like a saving grace to take away from all this, because it seems like it's all bad news. Like if we can have this many cases that arise due to a very small number of initial cases, but they can spread very quickly, the opposite must also be true. The earlier you reduce your sort of cases, the earlier you reduce these cases, the more impact it's going to have at the end. Because now the Australian government put out this little message here. It's why social distancing matters, right? So let's say one person infects 2.5 people every 5 days. After 30 days, they're going to infect 406 people. So you can see this idea of exponential growth, how quickly this happens, right? But if you have just 50% less exposure, right? Over the 5 days, it doesn't seem to make a big difference, right? You're only half the amount of people over the 5 days. Well, what's happened over here? It's significantly less. You'd expect, like, hey, wouldn't it just halve this number at the end as well? It doesn't, because of the fact and the nature of how exponential growth works. It's a multiplier, right? So the earlier you kind of can have an impact on the spread of these cases, the more it's going to do ultimately in the long run. And same thing over here, right? If you only infect, if you have a 75% less exposure, then again, we're going to have an even more severe impact on its reduction over here. Okay, so that's just like a little bit of an explanation of, why does exponential growth matter to you? Why is there something that we can take away from this? There's a lot we can take away.